Very good morning to all of you students. Welcome to the physics class, and your first chapter is most important, and the name of this chapter is electric charge and electric field. So student, it is the most important chapter according to your syllabus because in this chapter you will study the basic concept of electric field and direction of electric field and how can we apply the electric field at any point. So first definition is intensity of electric field. Student, the intensity of electric field is defined as the force working on a unit positive test charge. It means that if we applying a force on a unit test charge, then it will be equal to intensity of electric field. It is denoted by capital E, and capital E is equal to F upon Q naught, where Q naught is the force working on a unit charge Q naught and F is the force. The unit of intensity of electric field is Newton per Coulomb, and it is a scalar quantity. Q naught is a scalar quantity, but electric field is a vector quantity. Now, the next topic is force on a charged particle in an electric field. It means that when any charged particle enters in an electric field, then the force working on that particle will be equal to F is equal to Q into E, where Q is the charge and E is the electric field intensity. सर वीडियो बना रहा हूँ अभी खाली है ना. Now we will discuss the dimension of electric field intensity. As we know that intensity of electric field E is equal to F upon Q naught, then the dimension of force F mLT minus 2 and the dimension of Q is AT. So the dimension of electric field intensity will be mLT minus 3 A minus 1. Now electric field intensity due to a point charge. Take a diagram, take a point Q at point O at a distance small r, take another point P where we have to find the intensity of electric field. So take a test charge Q naught. Now we know that the force between two charges is F is equal to 1 upon 4 pi epsilon naught k q naught upon r square, where k is the constant for medium and it is known as dielectric constant. Now we know that intensity of electric field is equal to F upon Q naught. So on putting the value, we get 1 upon 4 pi epsilon naught k q upon r square. This is the required expression for electric field at any point. The next topic is in electric line of forces. It is also most important theoretical topic. Electric field lines are the imaginary smooth curve drawn in an electric field along any moving charge. If we draw a tangent at any point on the electric field, then it will show the direction of electric field at that point. Now, how can we determine the direction of electric field due to charges? If charge is minus q, then the direction of electric field will be towards, and if the charge is positive, then the direction of electric field will be outward from the charge. Now the next topic is properties of electric field lines. There are some most important properties are, first property is electric line of force originate on positive charge and terminate on negative charge. It means that they always starting from the positive charge and terminating on the negative charge. Second point is the tangent drawn at any point on the line of force gives the direction of electric field at that point. The third point is the two lines of force cannot intersect at a common point. It is the most important concept, because if they intersect at any common point, then at that point there will be two direction of electric field, which is not possible in any case. Next topic is electric field lines do not pass through the conductor. It means that they only passing outside the conductor. So these are the properties of electric field lines. Now the next topic is electric dipole. If we take two charges at a small distance, their magnitudes are equal but their directions are opposite. That means one is positive and second is negative. Then this construction is known as electric dipole. And electric dipole moment can be defined as the product of any charge and multiplied by the distance between these two charges. And it is given as P is equal to Q into 2L, where P is electric dipole moment and Q is the charge and 2L is the distance between these two charges. Now there is a derivation electric field due to an electric dipole. There are two conditions we can find the electric field intensity due to electric dipole. First condition is when the point is on the axis, and the second condition is when the point is on a equatorial line. So in the first case, take a dipole AB. Now take O as a center, and at a distance small r take another point P, where we have to find the electric field intensity due to electric dipole. As we know that the direction of electric field at point P due to plus Q charge is outside and minus Q charge is towards. Then E1 is the electric field E1 is the electric field due to minus Q charge, plus Q charge, and E2 is the electric field due to minus Q charge, and E1 is equal to 1 upon 4 pi epsilon naught Q upon R minus L whole up square, and E2 is 1 upon 4 pi epsilon naught Q upon R plus L whole up square. Now the now the net electric field at point P will be E is equal to E1 minus E2. On putting the values, we can find easily the values of electric field at point P, and it will be, on solving, we get so finally we get E is equal to 1 upon 4 pi epsilon naught 2 PR upon R square minus L square whole up square, and where P is Q is equal to 2L electric dipole moment, and we know that L square is very small in the compare of R square, then we can neglect L square in the compare of R square. So the required value will be E is equal to 1 upon 4 pi epsilon naught 2P upon R cube. Now the second condition is intensity of electric field at a point on the equatorial line of a dipole. So take a diagram. There is a electric dipole AB and O is the center. Take a point P at distance small r, which is a equatorial line, and at point P the direction of electric field due to plus Q charge will be E1 and it will be outside, and E2 is the direction of electric field at point P due to minus Q charge, it will be towards minus Q. The resultant will be E, which will be inclined at angle theta. So the electric field at point P due to both two charges will be E is equal to E1 cos theta plus E2 cos theta, and on putting the value of E1 and E2 and cos theta from the diagram, we get 1 upon 4 pi epsilon naught Q upon R square plus L square cos theta, and 1 upon 4 pi epsilon naught Q upon R square plus L square cos theta. So on solving, we get the required value E is equal to 1 upon 4 pi epsilon naught P upon R square plus L square 3 by 2. In the same way, L square is very small in the compare of R square, then we can neglect L square in the compare of R square. So we will get E is equal to 1 upon 4 pi epsilon naught P upon R cube. This is the required electric field intensity at point P, which is placed at the equatorial line. Now the last topic of this chapter is torque on a dipole in a uniform electric field. So there is a diagram. In this diagram, a dipole is placed in the electric field, and when it is rotated at an angle theta, then a torque is working on that electric dipole, and we know that the torque is tau is equal to force into perpendicular distance. So we can write tau is equal to force into perpendicular distance, and force is QE, and the perpendicular distance from the figure you can find 2L sine theta. So on putting the value we get 2QL E sine theta, and we know that P is equal to Q into QE. So tau is equal to PE sine theta, and we know that when multiplied by sine theta then it becomes a cross product, and on removing the sine theta we use the cross sign. So the required value of torque will be tau is equal to P cross E. So this is the required derivation. Now student, on the basis of above derivations and definitions, you can solve the questions and numericals of this chapter very easily. So try to solve these questions and numericals and enhance your knowledge. Here we will discuss a simple numerical number 6. It is most important numerical. 4-point charges QA, QB, QC and QD are located at the corner of a square, which is shown in the diagram, and the radius, the side of a square is 10 centimeter. What is the force on a charge of 1 microcoulomb placed at a center of the square? So here at point O there is a charge 1 microcoulomb. So first of all we will find the force FA, FB, FC and FD at point A, B, C and D, and after that at point O the resultant force will be F is equal to 0, because the values are same and opposites. So the required and net force on the center will be 0. So student, solve these numericals, and you can also solve numericals from your notebook. Thank you very much, and keep watching the videos. Thank you.